Okay, welcome Precalc C. Hello. We're going to do a short lecture right now about matrices. What is a matrix? This is a difficult question to ask, and the real answer I can't tell you right now because you wouldn't understand it. So instead, I'm going to give a bad answer today, and we'll give a better answer next class, and we'll give a better answer the class after that, and we'll keep sort of giving different sort of bad answers that are slightly better, and then at the end of the unit, in some ways you can think of this entire unit as trying to figure out what a matrix really is. And so sort of a week or two from now, we'll really get the answer to that question. Okay, the first answer is, what is a matrix? It's just like a box. It's just like a box of numbers, okay? It's a box of numbers. And what can we do with the matrix? One thing we can do with the matrix is do Gaussian elimination a little bit better. So, alright, take this example. I'm going to give you an example right now. This is the example. It's a system of equations, x plus y minus 5z equals 3, x minus 2z equals 1, 2x minus y minus z equals 0. Okay, here is my system of equations. And you know how to solve this system of equations via matrices. Great, sorry. You know how to solve this system of equations via Gaussian elimination. And this is what we practiced all this week that just ended. You know, make that a 1 and you do all the stuff. Okay, so all good. Well, I'm about to introduce a slight minor variant of that. And all we're going to do now is just have less to write. You might consider this to be sort of more organized or something. What I'm going to do is I'm just going to only write the coefficients. So this is 1, 1, negative 5, 1, 0, negative 2, 2, negative 1, negative 1. This is what's called the matrix of coefficients. Notice all I did was just took all these numbers and copied them over here. And then, okay, this vocabulary is really not important, but if I add these numbers here, this is called an augmented matrix. So the augmented matrix is the matrix with all the coefficients on the left and all the sort of answers on the other side. And okay, this matrix, we refer to this as a 3 by 4 matrix. A matrix has a certain number of rows, those are the ones that go horizontally, and a certain number of columns, those are the ones that go vertically, like the columns of a building. And we always talk about the size of a matrix by the number of rows and the number of columns, in that order. So this matrix is a 3 by 4. Okay, and I hope what you are sort of, and sometimes people put these little colons here to sort of remind you what's going on, but I'm going to do this once ever and then sort of never again. Okay. All we're going to do now is we're just going to do Gaussian elimination. That's it. No surprises. But all that's happening is by not having to write out all the variables every single time, it's just going to be less work and a little bit more efficient and a little bit cleaner and more smooth. That's really it. And yeah. It is, however, sort of more abstract, so you need to have that base of understanding of Gaussian elimination for this to be kind of comprehensible. But okay, well, let's just go. What's the first thing we do when we do Gaussian elimination? We make sure that number up in the top left-hand corner is a 1, and then we use that 1 to kill all the things beneath. Okay, so I'm going to replace row 2 with negative row 1 plus row 2, and I'll replace row 3 with negative 2 row 1 plus row 3. So 1, 1, and let's see, 0. Hope I'm doing this right. And yeah. Okay. I think that's looking pretty good. What else? Well, now I have sort of succeeded in making these numbers zeros. Now I need to, well, it's a couple of different things I could do, but one thing I might do is divide through by negative 3 here, just because I can. So let me do that. And also, I kind of want to make that a 1, so I'm going to make that a 1. So I'll replace row 2 with negative row 2, and I'll replace row 3 with row 3 divided by negative 3. So I get 1, 1, negative 5, 3, 0, 1, negative 3, 2, and here I get 0, 1, negative 3, 2. Aha! I've seen this kind of thing before, and now, leaning on my sort of experience with this, I know that this is like sort of like when I have a repeat equation. So already I can tell you that this is going to be a line, right? Okay, but let's just kind of proceed with the Gaussian elimination. One more step, as we saw in class, we can replace row 3 with negative row 2 plus row 3. And then we get 1, 1, negative 5, 3, and then this is all zeros. Okay, and now the Gaussian elimination simply stops because there's nothing more I can do. And so there's this, this triangle formation that I keep alluding to in class, and this can be made kind of now more precise or something, which is what we're really trying to do, is create a triangle of all sort of zeros down there in the bottom left-hand corner. If you can produce this shape, then there's a name for this. We say that this matrix is in row echelon form. Okay, this is not really so important that you know this phrase. Echelon is like the German word for staircase, I think, or something like that. So the idea is that it sort of looks like a staircase, right? Like or maybe go up this way. So staircase. It's in staircase form. Okay, are we done? Yeah, we're done. But we still have to finish the problem, but we're done with the matrices. And now I think you need to, here's where you need to have kind of the experience to not forget what's going on. Of course, with every added level of abstraction, it's possible that you just kind of forget what it is you're doing. Don't forget what you're doing, because what is this matrix really? This was kind of like a short and efficient way to do Gaussian elimination. And so the way to interpret what's happened here is x plus y minus 5z equals 3, y minus 3z equals 2, and that's it, right? So I think once you get comfortable with the matrix representation, you don't need to go back again, but if it makes you comfortable to sort of convert back from the matrix to the system, you can. And now we know how to finish it off from here, right? This system of equations can be interpreted as two planes which have an infinite number of points of intersection. They're going to intersect in a line, and therefore it means that these three planes must all intersect in a line. What is the equation of that line? Well, we just introduced this free parameter, so we let z be represented by this free parameter a, then y is 3a plus 2, and x is negative y, so negative 3a plus 2, plus 5z, so plus 5a, plus 3. And so that becomes 2a plus 1, I believe. Yeah. And the final answer to this problem, therefore, is 2a plus 1, 3a plus 2, comma a. So the solution to this problem is the infinite number of ordered triples of the form 2a plus 1, 3a plus 2a. Okay, so you might be thinking, dude, this is just not new at all. You are right. This initial exposure to matrices is just completely not a new concept at all. It's just doing Gaussian elimination directly on the numbers instead of having to rewrite the variables every single time. And I think the nice thing about this is because we've abstracted away from the equations and thought of it as just a box of numbers, you can now imagine, I think pretty clearly, that you can program a computer to do this kind of stuff. And pretty soon, you know, we are just going to let computers do this kind of thing for us. Okay. Good. I'm erasing this now, and we're going to do just one more problem, and that'll be it. Okay. And this other problem, okay, even though this is really not new, It's extra practice, and there's just some interesting little things that come up that will help you be better at Gaussian elimination. So, okay, let's go. I'm going to write kind of small because a lot of things here. So 2x minus y plus 3z equals 24. Also, I think my family's about to come home any second now, so there might be a lot of screaming children, perhaps in this video even. Okay, so here I have this system of equations. What should I do? Let's see, hold on. 1, 2, let me just count here. 1, 2, 3, 4, 5, 6, 7. Oh my god, 8, 9, 10. I need to fit 10 matrices on here. How am I going to do that? Yikes. Alright, I think somehow I'm just going to not. I don't know. Okay, I might have to go in a circle and then erase as I go or something crazy like that. Ah! Okay, well, let's begin. Step 1, I want to solve the system of equations. How do I do it? Gaussian elimination. How are we going to do it now? With matrices. So it's going to be 2, -1, 3, 24, 0, 2, -1, 14, 7, -5, 0, and 6. Okay, there is my matrix. Well, what should I do? Notice that the very first step, traditionally speaking, is to make this number up in the top left-hand corner a 1. So if I was a computer right now, I would divide row 1 by 1. But I'm not a computer, I'm a human being, so I'm going to do this in a kind of a human way. Even though this might be considered maybe more work, somehow it's just easier. And the human way to do this, yeah, I guess, well, okay, we'll see what happens. The human way to do this is to multiply this row 1 by 7. So you get 7 row 1 and multiply row 3 by -2. So -2 row 3. Okay, so I get 14. So just kind of stay with me here, right? So 7 is 21, and 7 times 24 is 140 and 28, so it's 168. Okay? And if you multiply this by -2, okay. Why did I do that again? I did that again because I wanted to avoid fractions, but I did want to well, I wanted to avoid fractions. And now the goal is to clear all the space down here. And so what I'm going to do next is just replace row 3 with row 1 plus row 3. Yeah. And now, by the way, I don't need row 1 to be so big anymore, so I can just divide back through by 7. Okay, so what's going on here is this row is staying the same. Okay, now I'm writing really big for some reason. But this row down here is going to be 0, 3, 21, and 156. Yeah. And then this row can be just can be shrunk back down again. So if you divide through by 7, it's just back to 2, -1, 3, 24. Okay, and I think you will agree that we made progress. Okay, what now? Well, one thing I notice right now, and maybe you do too, is that everything in this row can be divided by 3. So let's divide row 3 by 3, just because I can. So I get 2, -1, 3, 24, 0, 2, -1, 14. And then here, if I divide through by 3, I get 0, 1, 7, and 3 goes into 156 52 times. Okay, so that was just a lot of writing to get me to this nice spot. Notice what the next thing I'm supposed to do is. The next thing I'm supposed to do is make this number a 1. So a sort of not good move now, I think, would be to sort of divide this row by 1. Although you could do that, it would be fine, but it would make fractions. I don't want fractions. So here comes this smooth move that I mentioned sort of one time only ever, and you might have thought, what? you can swap the order of two rows. If the goal is to make that a 1, then one thing we could do is just replace row 2 with row 3, and row 3 with row 2. So on pain of having to sort of do a lot of writing, this is the smoothest way to do it. This is just, all I did here is just swap the order here. So I get 2, negative 114. Okay, and now, I'm just going to continue this on in a sort of a loop, erasing as I go, I guess. That's the only thing I can think of. Now, finally, I'm going to sort of finish the problem, and that is, I'm going to replace row 3 with negative 2 row 2 plus row 3 to get rid of this 2 that's right here. So, yeah. So this is 2. Negative 1, 3, 24. I still have this 0, 1, 7, 52. And now this becomes 0 and what am I doing? Negative 15 and negative 104 and 14 is negative 90. Okay, and now I'm sort of done with Gaussian elimination, you might think, because the last thing I maybe want to do is to divide through here by negative 15. So if I divide row 3 through by negative 15, then I get 2, negative 1, 3, 24, 0, 1, 7, 52, and this becomes 0, 0, 1, 6. Okay, if you remember, looking good, if you remember what is going on here, then you can interpret that third line as saying, like, 0x plus 0y plus 1z equals 6. In other words, this entire final row really just says z equals 6. And therefore, I'm just sort of done. I know that z equals 6. Then the normal thing to do now would be to plug 6 in for z and calculate what y would be and plug in dice. Okay, but alternatively, we can move on and we can do more things. Now, why would we ever want to do more work if we're sort of done with the problem? Well, one thing, one answer to that is that if computers are going to be doing this whole thing for us anyway, then we might as well tell them to go all the way to the end. So what does it even mean to go all the way to the end? Well, this is kind of the sort of the new topic of the day, so to speak, which is like there are more sort of things we can do. I need to squeeze sort of 3 more matrices in here. I think I can, yeah, comfortably. Okay. So, and maybe I'll just erase all this other stuff because it's sort of this is all sort of the past or something. Okay. So what is even possible to what more is even possible? Well, one thing I could do is with this 1 right here, I could use it to kill that negative 1 above it. In other words, let's get rid of the space above this 1 as well. And I think it's pretty clear how to do that. I'm going to replace row 1 with row 1 plus row 2. Yeah. So if I do that, I'm keeping rows 2 and 3 the same, but now row 1 becomes 2, 0, 10, and 76. I think I did that right. And this, and now the rest of this is just the same. 1, 7, 52, 0, 0, 1, 6. Okay, and now the goal here is to just sort of make as many zeros as possible. So I made a 0 here. Well, I can also use this 1 down here to clear all the space above it. And so now what I'm going to do is, leaving row 3 the same, I'm going to replace row 2 with negative 7 row 3 plus row 2 to kill that 7. And I'm going to replace row 1 with negative 10 row 3 plus row 1. So this stays the same, this 0, 0, 1, 6. But now, multiplying this row by negative 7, this gives me 0, 1, 0, and negative 7 times 6 is negative 42, and 52 is 10. Yeah, no, I'm doubting myself. And here I get 2, 0, negative 1, negative 10 times 1 plus 10 is 0, and negative 10 times 6 is negative 60, and 76 is 16. Okay, so now there are zeros almost everywhere, and there's just like one thing left to do, which is to divide that row 1 by 2. Okay, this is what's called taking it out to the bitter end. And if you take it out to the bitter end, I now have a matrix that is as simplified as it possibly can be. This is taking Gaussian elimination just like all the way, man. Not only do I go until I have this triangle of zeros, that I achieved already up here, right? And in the old way, we would stop here, and we would, or I guess we would stop here, right? That has a name. It's called Gaussian elimination. With back substitution. Okay, it's long and sort of boring name for just exactly what's happening. You do Gaussian elimination until you hit this point, and then you substitute back in the variable that you found to find the other variables. Okay, but what we did in these subsequent 3 steps is to sort of do more Gaussian elimination. And what we did was to also create this kind of triangle of zeros up there. And okay, if you don't see this, why is this so useful? Because you just want 100% done, right? Because the interpretation of this matrix is just this is just telling you x equals 8, y equals 10, and z equals 6. It's just you just read it straight off that matrix. And so the answer to this problem is 8, 10, 6. Okay, if you take this process on all the way to the end, that method is called Gauss-Jordan elimination. Gauss-Jordan elimination is just like Gaussian elimination, but with this extra part that Jordan added on to the end. And a matrix which is in this form is, we say that it is in reduced row echelon form. And reduced row echelon form is like the all the way form. Okay, so the only reason to know about this is because, one, it's not that hard. It only takes a couple extra minutes, and it does like fully and completely solve the problem. You have all zeros here, you have all zeros here, and you keep dividing until you make all these ones, and then this final column just is the answer to your problem. The other reason to be aware of this is that if you use technology, which we're going to be using for like for the homework due next week, then this is the format that it will give your final answer in. It will sort of do all this extra work for you if you hit the right button. And you should expect to see your matrices kind of in a form like this. Okay, good. I will see you next week. Goodbye.